Yeah. So let's talk about NumPy. See, NumPy stands for, this is nothing but numerical Python. Okay, that's it's NumPy. So what is this NumPy? NumPy is a Python open source library consisting of like multi-dimensional array object and collection of routines for processing the arrays. Okay, in a simple terminology. So NumPy is a Python open source library which is specially designed for performing the um, you know numerical calculations using the multi-dimensional array. Over here we can use the multi-dimensional array. NumPy is an open source Python library which is used for um, used or which is specially designed to perform numerical calculations using multi-dimension array. Multi-dimensional array over here. So we'll talk about what is this multi-dimensional. Okay, dimensional array. Okay. Now, we should understand one thing. NumPy is specially designed for the numerical calculations. Okay. So, the NumPy core component, the most important object, we can say it, in NumPy is array. Okay, this is like n-dimensional array, which we call it as MD array. So NumPy, I can say that core component which is used to store data, and says here data is numbers, data is which is used to do the core component of the data which is used to store data is array. Okay. And so the most important object defined in NumPy is an n-dimensional array. Okay. Now this n-dimensional array is which is referred as MD array. Okay. So basically NumPy means it is a library which is specially designed to perform the numerical calculations. First thing. Okay. Now NumPy core component which is used to store data is array. Remember that. Everything rotates around array. Okay. So, okay. Next one is the most important component, important object defined in the NumPy is ND array. So it is an ND array is nothing but it stands for n-dimensional array. Okay. It is nothing but n-dimensional array. Now you can perform now you should understand one thing. So this is specially designed to perform numerical calculations. Now, without this, we can't perform the numerical calculation means no, it's not like that. You can perform the numerical calculations, but you have to apply the logic on your own, or you have to write the code, entire code of performing some operations, numerical operations like algebraic or calculus, where you have to do it on your own. So to avoid that, the Python people released this library called as Numpy. Okay. Now, see, why we have to learn the Numpy. See, Numpy in a sense, Numpy is having a proven architecture. Okay. So Numpy architecture is already proven. Okay. Now I'm going to tell you quick history. I will tell you, then you will understand. So this, as it is having a proven architecture, so Numpy the architecture of the Numpy is being adopted by the other Python libraries. Okay. Now Numpy architecture used by other Python libraries. Like there is something called as pandas, there is TensorFlow, there is Keras, there is you can say it as SciPy, and Matplotlib, Seaborn, and many more. These all are Python libraries which are based on the Numpy architecture. So now, if it's not mandatory that if you know to learn them, you should know the Numpy. But if you learn the Numpy, that it is very easy for you to learn these libraries. Okay, so that's the reason why before learning all these libraries, so Numpy is pretty much like a mandatory. I can't say 100% mandatory. It is always better to learn Numpy before getting it, because you will be learning all the core components over here, which no need to do it. Now, if you take TensorFlow, like TensorFlow is just a replica of Numpy. Okay, only thing is that here we use the array, there we use the tensor. But if you look at them both, they both are arrays only. Okay, here our core component is array, as I told you. There in the TensorFlow, we call it as tensor. But if you look at both of them, the both are identical. So it's like that. That is the importance of this, Numpy. So quickly taking forward. Here. Okay. Now let's quickly look at the history of the Numpy, guys. So see, we all know that the Python was initially released in the year 1991. Okay, 1991, the Python was released. So right away after Python, after a couple of years of Python, so these people were getting the request, like in 1994, 95, 93, 94, like that. They were getting the request to build or develop a library which can specially used for numerical calculations. Like, as I said it, like algebra, with calculus and all these things. Okay, so Python people, what they did it is in 1995. In fact, it was a bit early. So in the year 1995, 1995, Python people, okay, released a new library by the name numeric. It is referred as numeric. Okay. Now this was developed by a group which was built which was gathered by the Python people. They call it as SIG group. SIG group developed this one. So this SIG stands for Special Interest Group. Okay. In 1995, they released a library called as numeric, which can be used for numerical calculations. Okay. Now this was developed by the SIG group. Now this library, when they released it, this was the SIG group, which was led by two people by the name Jim Fulton, okay, and Jim Huguenin. These are the two people who were leading this SIG group. Okay, and they were the ones who were developed this numerics. Again, there were other people were there. These two were like they gave it a 100% contribution for this library. Now there was a drawback with this library. What is that? Numeric. Numeric was pretty good in performing the simple calculations. Okay, so it can perform numeric. I can say it as numeric can perform simple calculations perfectly. Perfectly in a sense, like it can do it with a perfect precision, and also it was very, very fast. Okay, but the same numeric failed to perform the complex calculations. Complex calculations. Okay. But now again, it was a wrong because the people, the customers were mainly they were asking for this complex calculations. So, and of course, there half of the work is being done over there, but still they were waiting for the people to come up and like they were waiting for a library which can stand up to calculate the complex calculations. Okay. So now, after this was initially released in 1995, so the SIG group was like even SIG group got updated with the new people, and they were constantly working to build a library which can perform the complex calculations. So in 1997, same SIG group they released a new library called as NumArray. They called it as NumArray. Now the beauty of the NumArray is it can perform the simple calculations and complex calculations. Okay. Calculation. But the major drawback with this one NumArray is, see, its architecture was completely different than that of numeric. Numeric was altogether a different architecture. NumArray was completely different architecture. So the major core focus of the NumArray was to make the library work on the complex calculation. So in this process, what they did is they changed the complete architecture. Now, when they change the complete architecture, what's the problem it was having is, we can't say it as it's a problem. So what was it was having is, if you are doing with, okay, if you are yeah, what you can say it as, the simple calculations and complex calculations, it was taking the same time. But in the numeric, it was doing the simple calculation pretty fast. But here, as the complete architecture got changed, the simple calculations and the complex calculations both are taking same time. It is not doing the simple calculations faster compared to that of complex calculations. So now gradually the performance of this num array was reduced. Okay, gradually the performance of the num array was reduced because it's simple calculations it was taking more time. So the customers who wanted to do the simple calculations, they were going with the now numeric, and the customers who wanted to do the complex calculations, they were going for the num array. So now this is the biggest problem or biggest headache for the Python people. Why means, uh, they have to maintain two libraries. They have to maintain the two libraries, and they want to give the updates for the two libraries, and which they perform like similar kind of tasks. Numeric will perform similar kind of task, and the num array was performing similar kind of task. It was a headache for the Python people to maintain two libraries. So again, you should understand over here. So I will just put on major drawback of num array is slow or time taking to perform simple calculations. Okay, it is time taking to perform simple calculations. So to avoid this, now there was a gentleman. He was working from past 7 years, like on this, you can say it as 8 years on. In 2005, there was a gentleman by the name Travis. He's still there. Now Travis Oliphant. Okay, this Travis Oliphant, he came up with altogether, he merged the features of numerics and NumPy, num array, and he released a new library called as NumPy. Okay, Travis Oliphant. He is a guy who merged, or he combined, the numeric plus num array. And he released altogether a new library called as NumPy. Like this, it is actual NumPy, numerical Python. This was in the year 2005. Now, actually, if you look at this, the NumPy initially started with the numeric, then it went on with the num array, and then it transformed itself into the NumPy. So it went on for like the entire development of this library. They until it come down to a stable position as NumPy, it went on over a decade. So all ups and downs, it is being seen. Also the requirement and all those things. So what exactly happened was, this proven architecture, it got proven with the requirement. So the people started using the NumPy architecture as a foundation for building up the other libraries. Now, for each and every library, you can't spend 10 years, right? We already having a proven architecture. So that's the reason why the pandas use this, TensorFlow use this, and Keras use this, SciPy use this, and all these things. Okay. Now, again, you should understand one thing. Is before the are like we are not having an alternate of the NumPy. See, NumPy is a data structure which can hold. I will explain you what is data structure. Just give me a minute. So the NumPy is an array. Okay, it is just like an array which can hold the numerical data. Now, again, don't ask me the question. Usually people come up and ask the question that, okay, can we use the categorical data? Now, that is nothing but the string format of the data. See, the NumPy is specially designed for numerical calculation. Okay, it is specially designed for numerical calculations. Then why the hell, like, we will be looking at the like categorical data. Okay, so the specially designed for numerical calculation. Yeah, the extension of NumPy is pandas. Pandas is the one which deals with the all type of data. It deals with the categorical data, that's the string type of data. It deals with the numerical data, everything. It can deal with the everything. Okay, so this is how, the quick history of this. Okay, now when we look at the one of the major advantages of NumPy over the other Python objects. Now, you can take the competitors of the NumPy is, first thing is list or tuple or set or dictionary. These all comes under as a like alternate objects of the Python. So when it comes down to the NumPy versus list, you can take it as. Now you can, one of the three major advantages of the NumPy over the list. The first thing is NumPy is very fast in execution. It's very, very fast compared to that of list. Second advantage is NumPy occupies less memory compared to that of list. Okay. Now, third important thing is NumPy is very flexible to perform calculations compared to that of list. These are the three major advantages of NumPy. Okay. So we know now what is NumPy. NumPy is a library which used to perform the numerical calculations, first thing. So the core, very much core component of the NumPy is array. And array, it can hold n-dimensional array. Okay, I will explain you quickly about that n dimension. Now, NumPy is such a proven architecture that it is used in the other libraries. Okay, it is based on the NumPy architecture. These libraries, these are popular libraries of the Python. And this is a quick history about this. And NumPy advantages of NumPy over the list. Now, list is having, like, it's very flexible. List is really very flexible compared to that of other, Python objects. And over the list, the major advantages of the NumPy is these three are the advantages. Okay. Now, yeah. Now, let's see this. The Python, the NumPy is again it's slightly different than the other normal Python. Now I'm talking about the Python 3.x. There's NumPy is slightly different. That's the reason why these are advantages of the NumPy over compared to the other Python objects. Okay.